All right, taking a look at example 3. Back in 2005, a study was done investigating whether Olympic athletes in a certain uniform color have an advantage over their competitors. So, for the sports listed, they are either assigned a red or a blue uniform. And for every match in the 2004 Olympics, they recorded the uniform color of the winner. So out of 547 matches, the competitor wearing red won 248 times. Okay, use the 5% level of significance to determine if the competitor wearing red will win at a rate different than 50%. So first of all, is this binomial? So is every match independent of every other? Well, yes. Okay, one boxing match has nothing to do with another boxing match, let alone taekwondo, wrestling, etc. Okay, and then we have like either the red wins or the red doesn't win. So yes, indeed, this is binomial. And is n the sample size of 457 matches times, again, we have to assume it's a 50-50 split, right? 50% times 50% greater than or equal to 10. Yes, indeed, it is. So, what is the null hypothesis? The null hypothesis is that the person wearing red should win half of the time. Okay, now here's kind of where this comes up. It says, will they win at a rate different than 50%? So we don't have any indication here as to whether they think the person wearing red will win more or less than 50%. They're just saying it's not 50%. So in that case, we're going to select the not equal to 0.5. Okay, so this is going to be a two-tailed test when we start looking at it from that perspective. So using your calculator, you should put in the null hypothesis value of 0.50. Our X is the 248 people who were wearing red and won out of the 457 total matches that were studied. And we are doing the not equal to test. This is a two-sided test, okay? So p hat, again, pulling that from the calculator, is 0.5427. Our z value is 1.8243. And the p value, rounding to 4 decimal places, is 0.0682. So what should we do? All right, now I know this is a two-tailed test, okay? Still a two-tailed test. However, just because it's a two-tailed test, it just means that we essentially have 5% on each end, and then where is it that our results happen to fall? Okay, so 5% on each end. This is the reject zone, okay? Now, since the red won at a rate higher than 50%, okay, so the 50% here would kind of be in the middle. This is where a 50% of competitors would be. Our p hat value was at 54%, so we know that we're on this side. So this p value here of 0.0682 falls again into this zone, remembering that this is 5% of the area. So in this case, we're not going to reject. Let's see. I'm going to do not reject H sub 0. Okay, so then what goes in my blank here? We do not have enough evidence to support the claim that competitors wearing red win at a rate different than 50% of the time. All right, rather than making a video for example 4, I'm going to have that one posted as a discussion in the forum. So please do work through it. And I'm going to be asking what we found for a conclusion and a p-value. So basically like E, F, and G, we're going to specifically talk about those as a group in the forum. So please go there to join in on the conversation.